Let us now discuss the next model from this topic, where we are going to discuss puzzle type of questions which can be solved by using the concept of HCF or LCM as required. Let us look at the first example. The question here is, what is the least number of square tiles of uniform size required to pave the floor of a rectangular hall of length 20 meters and breadth 16 meters? So as given in the question, there is a rectangular hall of length 20 meters and breadth 16 meters. And the flooring of this hall has to be done with the help of square tiles of uniform size. So we need to decide what will be the least number of square tiles required to do the flooring of such a hall. Let us try to understand how to solve this question. As given here, there is a rectangular floor of length 20 and breadth 16. Let us assume the length here is 20 as given and the breadth is as shown, 16. So this is a rectangular floor, and the flooring of this hall has to be done with the help of square tiles of uniform size. That means all the tiles have to be of equal size. Now as we can understand, when the flooring is done here with the help of square tiles, it may appear as shown. Now our job here is to find out what will be the minimum number of tiles required to do the flooring. The point to be understood here is, if we want to do the flooring with the help of uniform square tiles, the side of the square tile should be a factor of both length as well as the breadth. Why? Because it has to balance both the length and breadth in terms of its size. So one point which is clear here is, the side of the square tile should be a factor of both length and breadth. And as given in the question, least number of tiles are required. Now for the number of tiles to be least or for the number of tiles to be minimum, the size of each tile has to be maximum. So in order to take the maximum size of each of these square tiles, we should try to take the maximum factor for both 20 and 16. That means here we are looking for a factor which is common to the length as well as breadth, and that should be the highest common factor. Why? Because we want the number of tiles to be minimum. So if the number of tiles have to be minimum, the size has to be maximum. So we can understand that the size of the tile, or we can say the maximum size of the tile, will be equal to the highest common factor of length and breadth. So in this particular case, the size of the tile can be taken as highest common factor of 20 and 16, which is the length and the breadth respectively. And when you do the calculation, this size comes out to be 4. So we can say that the size of the tile should be equal to 4 meters. That is nothing but the side of each tile. Let us take it as S. And the given question is, what is the least number of tiles required? Now the number of tiles that are required is nothing but the area of the rectangular hall divided by area of each square tile. So the minimum number of tiles that are required can be taken as area of the rectangular hall, divided by area of square tile, area of the square tile. So the area of the rectangular hall, that is length into breadth, divided by area of square, is S square. So it can be taken as 20 into 16 divided by 4 squared, as the side of the square tile is equal to 4 meters. Now 4 square and 16 gets cancelled, and the answer here would be 20. So we can say that 20 tiles is the minimum that is required to do the flooring of such a hall with the help of uniform square tiles. So the two important points that we need to understand here is, the maximum size of the tile should be taken as the highest common factor of length and breadth. And the number of tiles, the minimum number of tiles, will be nothing but the area of the rectangular floor by the area of each square tile. And area of each square tile is nothing but the size squared. That size here is nothing but the side of the square tile. So this is how we can solve this question based on the concept of highest common factor. Now here two types of question can be asked. Either the maximum size or the largest size of the tile is required. So that can be taken as highest common factor of length and breadth, and we can stop here itself. That means the answer will be 4 meters. And in some questions, the minimum number of tiles are required. So minimum number of tiles should be taken as area of the rectangular floor by area of square tile. So area of the rectangular floor is length into breadth as given in the question, and area of the square is side square, where the side is as obtained in the previous step. So depending on the question, you can either stop at this point or do the complete calculation to get the required answer. Let us now take the second example from model 8, where again we are going to discuss a puzzle type question. The question here is 3 bells ring at regular intervals of 3 minutes, 4 minutes and 8 minutes respectively. At what time will all the 3 bells ring together if all start ringing from 10 a.m. onwards? And the given options are 10:15 a.m., 10:30 a.m., 10:24 a.m., 11 a.m. and 10:36 a.m. So as we can see here, there are 3 bells which ring at regular intervals of 3 minutes, 4 minutes and 8 minutes respectively. And all the 3 bells started ringing from 10 a.m. onwards. So we need to find out that time when all the 3 bells will ring together. So we have to find out that instant of time when all the 3 bells ring together. Now as given here, let us assume that the 3 bells are B1, B2 and B3. Now the first bell rings at regular intervals of 3 minutes. So it will ring after 3 minutes, then again after 6th minute, 9th minute, 12th minute, 15th minute and so on. Similarly, the second bell here rings at intervals of 4 minutes. So it rings after gaps of 4 minutes, 8, 12, 16, 20, 24 and so on. And similarly, the third bell rings after every 8 minutes. So it rings after 8 minutes, then at 16th minute and 24th minute, 32nd minute and so on. As given in the question, we need to find out that time when all the 3 bells ring together. Now from this we can understand that the first bell rings after 3rd minute, 6th minute, 9th minute, 12th minute, 15th minute and so on. Similarly, the second bell rings after 4th, 8th, 12th, 16th and so on. And the third one rings after 8, 16, 24, 32 and so on. So we need to find out that particular instant which is common in all the 3 cases. So that is nothing but the common multiple for all these 3 cases. So as you can see, these are all the multiples of the regular time gaps, and if we find out the least common multiple, we get the required answer. So the answer here would be the LCM of the regular time intervals, that is 3, 4 and 8 minutes. Now as we have already learned, whenever we have a number which is a factor of some other number, then the LCM can be directly taken without considering that number. So the answer here should be LCM of 3 and 8. And since 3 is a prime number, the LCM directly can be taken as 3 into 8. So the answer here is 3 into 8, that is 24 minutes. So very clearly, these 3 bells will ring together after 24 minutes. So if they start ringing from 10 a.m. onwards, the time at which they will ring together again will be 10 plus 24 minutes. 10 a.m. plus 24 minutes. That is 10:24 a.m. And this is given in option number 3. So this is how we find out the answer for this question based on the LCM. So as you can see from these 2 examples, the question may either be based on the concept of highest common factor or least common multiple. We have to properly understand that should we go for LCM or HCF, and then we can find out the required answer. Generally, a question which is based on regular time gaps is always a concept of LCM. And similarly, a question which is based on measurement is always based on highest common factor. For example, a similar case, for example 2 here can be given as 3 persons who are running around a circular stadium, and they can finish around after 3 minutes, 4 minutes and 5 minutes respectively. So after what time will they come at the starting point together if they all start at the same time? So as you can see here, they are going to take different times to cover each round. So as we can understand from this question, each person will come to the starting point after regular time intervals. So even this type of question has to be solved based on LCM. So simply remember, a question which is based on regular time intervals is generally a case of least common multiple. Similarly, in example 1, we have seen that there is a rectangular floor which has to be paved with uniform square tiles. So that's like a case of measurement where we have to measure the size of the tile. So such questions which are based on measurement are generally the cases of highest common factor. So based on the given question, we first need to decide is it a LCM based or a HCF based question, and then go for the solution. So that's all from LCM and HCF. Practice well on all the models discussed. See you in the next session. Thank you.